Hello there and welcome to Lower 6th Further Maths A-Level. This is the practice paper with questions from June 2015, and here we have a vectors question. So we have points A, B and C at these vectors here. They're effectively coordinates written in the column style. Find the vector equation of the line from A to B. Okay, nice, straightforward, easy one. Remember, to work out the vector that goes from A to B, we use coordinate B, take away coordinate A, so that's going to be minus 1, 0, 1, take away 1, 3, 2, which is going to give us minus 2, minus 3, minus 1. And what we'll then do is write out the equation of the line from A to B. So this is going to take us from 1, 3, 2, add lambda lots of minus 2, minus 3, minus 1. Now remember, with direction vectors you can always simplify their vectors. Now what I'm going to do here is effectively pull out the negatives from all of these. If they were all even, then I could divide them all by 2. They're still travelling in the same direction. It would be effectively, the lambda would have to be minus 1 to get back to B. So I'll just simplify my vector so it's looking like that, a bit nicer. Find the Cartesian form of the equations of straight lines A to B. So here, just remember the Cartesian form of a vector goes x minus a1 over b1. And the a1 comes from this value 1 at the top here, and the b1 comes from this 2 here. And we go along doing exactly the same. Y minus a2 over b2 equals z minus a3 over b3. Now we can just plug the numbers in here. We've got a1, a2, a3, b1, b2, b3. So it's going to be x minus 1 over 2 equals y minus 3 over 3 and 2, so z minus 2 over 1. Okay, so that's the Cartesian form of the equation. Moving on to the next part, the plane contains the points A, B and C. Find the equation of the vector of the plane in the form r dot n equals p. So what we've got is we've already got our vector from A to B. That's going to be 2, 3, 1. So the equation of our plane is going to be 1, 3, 2. Add lambda lots of, I've already forgotten it, 2, 3, 1. And now we need a third part of our vector that will get us from A to C. So we need to go up 1, we need to go down 2, and we need to go down 2 again. So that's how we get from A to B. So now what we're going to do is we're going to put this in r dot n form equals p, by creating some simultaneous equations out of these equations here and rearranging them. Now effectively what we have is the x-coordinate is going to be calculated by 1 plus 2 lambda plus a mu. So that's what we can write. We can write the x-coordinate equals 1 plus 2 lambda plus mu. The y-coordinate is calculated with these middle values, so we're going to get 3 plus 3 lambda minus 2 mu. And for this one here, we're going to get z equals 2 plus lambda minus 2 mu. Okay, now what we've got to do, we can't solve these simultaneous equations, but what we can do is eliminate mu and lambda to give us an equation just with x, y's and z's in, and I'll show you where to go from there. So what I think I'll do first is I will rearrange to make lambda the subject of the last one, so it's going to be z minus 2 plus 2 mu. And then I'm going to substitute this into both the x and the y equation. So it's going to be 1 plus 2 of this lambda, so that would be 2z minus 4 plus 4 mu. And then we plus the mu on at the end. And the y equation is going to be 3 plus 3 lambdas, that's going to be 3z minus 6 and plus 6 mu. And then we take away the 2 mu. So simplifying both of these now, we're going to get x equals 2z plus 5 mu minus 3. And we're going to get y equals 3z. We get a minus 3 as well. And we're going to get plus 4 mu. Okay. So what I think I'll do here is I will quadruple the first formula and times by 5 on the second equation, and then we'll do some subtraction. So we'll do 4x equals 8z plus 20 mu minus 12, and we're going to get 5y equals 15z plus 20 mu minus 15, and we'll subtract these equations away from each other. So we're going to get 4x minus 5y equals minus 7z. The mu's will cancel, and in this case here we're going to get a plus 3. Perfect, good. Okay, so let's just rearrange this. So it's 4x minus 5y plus 7z equals 3. So therefore, in r dot n form, the n part is going to be 4 minus 5, 7, straight from the coefficients of this Cartesian form. And the p part here, that's going to equal 3. Okay. Now part D asks us to find the shortest distance from the origin to the point pi. So what we can do here is pull out our formula, which is n1 alpha plus n2 beta plus n3 gamma minus d modulus over square root 4 squared plus 5 squared plus 7 squared. So yeah, sorry, I've substituted these n1, n2s, n3s in already, haven't I? So this bit here is going to equal 0 because it's the origin. Alpha, beta, gamma are all going to equal 0, so scratch all them out. And then this one here on the top is just going to be a 3. Okay then, so once you've worked this out, you're going to get 3 over root 90. And this is going to give us 1 over, the 9 can come out as a root, so it'd be root 10. Okay, so that's the answer to question 10, 8 marks in total for that.